The calendar read December 27, 1940, when the United States Maritime Commission finalized a contract that would fundamentally alter American industrial capacity. The agreement called for construction of 30 cargo vessels designated for British use to be delivered within a 24-month timeframe. The signatory was Henry John Kaiser, a 58-year-old industrialist whose resume listed dam construction, highway projects, and cement production, but contained no maritime engineering experience whatsoever. This contract emerged from desperate strategic necessity. Throughout 1940, German U-boat operations in the Atlantic had accelerated to crisis levels. Admiralty records from late 1940 indicate that Allied shipping losses exceeded 4 million gross tons that year alone. British Prime Minister Winston Churchill would later characterize this period as the moment when defeat seemed most probable, stating in his memoirs that the Battle of the Atlantic represented the only campaign that genuinely threatened Britain's ability to continue fighting. Traditional American shipyards operated under methods essentially unchanged since the early 20th century. A standard cargo vessel required 6 to 8 months of construction time, involving teams of highly specialized craftsmen. Riveters, fitters, caulkers, and plate workers followed apprenticeship programs lasting 3 to 5 years. The shipbuilding establishment viewed their profession as an art form, where expertise accumulated over decades produced vessels of exceptional quality and longevity. Kaiser's background lay entirely outside this maritime tradition. Born in upstate New York in 1882, he had built his reputation through large-scale civil engineering projects during the 1930s. His portfolio included major portions of the Hoover Dam, Bonneville Dam, and Grand Coulee Dam, projects characterized by aggressive timelines, innovative construction techniques, and massive labor coordination. When the Maritime Commission solicited bids for emergency cargo vessel construction, Kaiser submitted a proposal that industry veterans dismissed as technically impossible and financially reckless. The established shipbuilding firms, Todd Shipyards, Newport News, and Bethlehem Steel, possessed the expertise but lacked the capacity to meet wartime demand. Their yards operated near maximum output, and expanding traditional facilities required years of investment. Maritime Commission Chairman Admiral Emery Scott Land faced an impossible equation. Britain needed hundreds of cargo ships immediately, but American capacity could deliver perhaps a few dozen annually using conventional methods. Kaiser's proposal offered a solution that contradicted every principle of traditional naval architecture. He suggested applying mass production techniques, specifically those pioneered by automotive manufacturers, to ship construction. If you're finding this examination of industrial innovation during the Second World War valuable, please subscribe to support evidence-based historical research. Let us know in the comments which country you're watching from and what other wartime production topics you'd like explored. The Liberty ship design itself originated from British specifications. In 1940, the British government commissioned a modified version of a tramp steamer design, seeking a basic cargo vessel that prioritized carrying capacity and production speed over performance characteristics. The resulting blueprint specified a vessel measuring 441 feet in length, 57 feet in beam, with a deadweight capacity of approximately 10,800 tons. Naval architects designated this the EC2S-C1 type, Emergency Cargo Second Design Steam Engine C1 construction standard. These specifications deliberately emphasized simplicity. The design employed a single-screw propulsion system, triple expansion steam engine producing 2,500 horsepower and a maximum speed of 11 knots, substantially slower than existing cargo vessels. Traditional shipwrights viewed these compromises as evidence of British desperation rather than sound engineering. However, Admiral Land recognized that adequate ships delivered rapidly would serve Allied strategy far better than superior vessels that arrived too late or not at all. Kaiser's December 1940 contract represented calculated risk by the Maritime Commission. Officials privately doubted his ability to deliver even half the promised vessels on schedule. Internal memoranda from early 1941, now declassified, reveal that Commission staff considered the Kaiser contract primarily a hedge. If traditional yards met their quotas, Kaiser's inevitable failures would prove inconsequential. If traditional methods fell short, perhaps Kaiser's unorthodox approach might yield a few additional hulls. Kaiser assigned his chief engineer, Clay Bedford, to investigate automotive production techniques at Ford Motor Company's River Rouge complex in Dearborn, Michigan, during early 1941. Bedford spent 3 weeks observing assembly line operations, documenting the systematic breakdown of automobile construction into discrete, repeatable tasks. Each worker performed a single operation, installing a component, tightening specific fasteners, or applying a coating before the chassis advanced to the next station. This observation led Bedford to a fundamental insight. Ship construction could be reorganized using identical principles. Traditional shipyards built vessels sequentially, with each stage dependent on completing previous work. Riveters couldn't begin until plate fitters finished positioning steel sections. Interior fitters waited for hull completion. Equipment installation occurred only after structural work concluded. This sequential process created inherent delays, as specialized crews sat idle while preceding teams completed their tasks. Bedford proposed radical restructuring. Instead of building ships sequentially at a single slip, Kaiser's yards would fabricate major sections simultaneously at separate locations. Bow assemblies, stern sections, midship cargo holds, engine rooms, and superstructures would be constructed as complete modules, then transported to a central assembly area for final integration. This approach, termed prefabrication, would transform ship construction from a craft-based sequential process into an industrial parallel operation. The technical innovation enabling this restructuring was welding. Traditional ships utilized riveted construction, heated rivets hammered through overlapping steel plates to create joints. A single Liberty ship design required approximately 300,000 rivets, each installed by a team of 4 workers: a heater, a catcher, a holder, and a driver. Riveting demanded precise coordination and years of experience to achieve proper joint integrity. Welding offered multiple advantages. The process joined steel plates by melting their edges together, creating a continuous joint rather than a series of discrete fasteners. Welded joints weighed less than riveted equivalents, increasing cargo capacity. Welding required fewer workers per joint. One operator could complete work that previously demanded 4-person teams. Most significantly, welding could be taught in weeks rather than years, enabling rapid workforce expansion. However, welding at shipbuilding scale remained largely experimental in 1941. The American Bureau of Shipping, which established construction standards for maritime vessels, had limited data on welded ship performance under ocean conditions. Naval architects worried about stress concentration at weld points, potential for crack propagation, and fatigue failure under repeated loading. The established shipbuilding industry viewed Kaiser's welding proposal as dangerous cost-cutting that would produce vessels prone to catastrophic failure. Admiral Land initially shared these concerns. Maritime Commission engineers conducted extensive metallurgical testing throughout 1941, subjecting welded joints to stress tests, impact tests, and fatigue cycling. Results proved more favorable than anticipated. Properly executed welds demonstrated strength exceeding riveted joints, and the continuous joint design actually reduced stress concentration compared to riveted construction. By mid-1941, the Commission cautiously approved welded construction for emergency cargo vessels, while maintaining reservations about long-term durability. Kaiser selected Richmond, California, as his primary shipyard location. The site offered several strategic advantages: deep water access to San Francisco Bay, proximity to Western Pacific shipping routes, available flat land for yard expansion, and access to regional rail networks for material transport. Most importantly, Richmond lay outside the established shipbuilding centers of the East Coast, allowing Kaiser to build facilities according to his specifications without interference from traditional industry practices. Construction of Richmond Shipyard No. 1 commenced in January 1941. Rather than building traditional narrow slips with fixed gantry cranes, Kaiser's engineers designed wide-open assembly areas serviced by mobile cranes capable of lifting entire ship sections. The yard layout resembled an automotive factory more than a conventional shipyard. Separate fabrication shops produced standardized components, bulkheads, deck sections, mast assemblies, which moved along rail lines to staging areas for integration into larger modules. Kaiser's production system required a fundamental rethinking of labor organization. Traditional shipyards employed workers who had completed multi-year apprenticeships, developing expertise through gradual exposure to increasingly complex tasks. This apprenticeship model ensured high-quality craftsmanship, but created severe workforce constraints. The United States possessed approximately 75,000 experienced shipyard workers in 1940, a workforce sufficient for peacetime production, but grossly inadequate for wartime emergency construction. Kaiser's solution was to decompose skilled trades into narrow, teachable tasks. Rather than training complete shipfitters, workers capable of performing all aspects of hull assembly, his program produced specialists who mastered single operations. One worker learned to position plate edges for welding, another learned to execute the actual weld along a seam, a third learned to grind and finish the completed joint. By fragmenting complex skills into simple procedures, Kaiser reduced training time from years to weeks. The first training classes began in Richmond during spring 1941, initially producing skepticism among both instructors and students. Could a person with no industrial experience genuinely learn to weld ship-grade steel in 3 weeks? Early results proved mixed. Defect rates ran high, and experienced supervisors spent considerable time correcting errors. However, Kaiser's system incorporated rapid feedback and continuous refinement. As instructors identified common mistakes, they modified training curricula to address specific problems. Inspection procedures caught defective work before it progressed to subsequent stages. By mid-1941, the training program had achieved sufficient maturity to support rapid workforce expansion. Kaiser recruited aggressively throughout California and neighboring states, offering wages substantially above agricultural or service sector employment. Advertisements emphasized that no previous experience was required, only willingness to learn and capacity for physical labor. Thousands responded, drawn by economic opportunity and, increasingly, by patriotic motivation as war approached. The workforce composition reflected Kaiser's willingness to hire populations excluded from traditional shipyards. Women constituted minimal presence in conventional maritime construction, relegated primarily to administrative roles. Kaiser's yards employed women as welders, crane operators, and equipment installers from the program's inception. By 1942, female workers comprised approximately 20% of Kaiser's workforce, a proportion that would increase substantially after Pearl Harbor. African American workers similarly found opportunities in Kaiser's yards that remained closed at most traditional facilities. While racial discrimination persisted, black workers often faced harassment and were excluded from certain positions. Kaiser's yards provided access to skilled trades and union wages that represented significant economic advancement. Thousands of black families migrated to Richmond and other Kaiser shipyard locations, creating demographic transformations that would reshape West Coast cities for decades. The training program's success depended on systematic skill decomposition. Kaiser's industrial engineers conducted time-motion studies of experienced shipbuilders, documenting every action required to complete specific tasks. These studies revealed that supposedly complex skills actually consisted of learnable sequences of simple operations. Welding, for instance, required proper electrode angle, consistent travel speed, appropriate current setting, and steady hand movement, each element teachable through demonstration and supervised practice. Training facilities operated around the clock, with new classes starting weekly. Students spent mornings learning theory and observing demonstrations, then spent afternoons practicing on scrap steel under instructor supervision. After completing basic training, new workers entered shipyard production under close supervision by experienced leads. This graduated approach allowed rapid workforce expansion while maintaining quality control. The first Kaiser-built Liberty ship, SS Patrick Henry, was launched from Baltimore on September 27, 1941, 197 days after keel laying. This completion time while exceeding Kaiser's optimistic projections, substantially undercut traditional shipyard performance. More significantly, the vessel met all Maritime Commission specifications and passed sea trials without major deficiencies. Kaiser's welded construction approach had been validated. Production acceleration became systematic priority throughout 1942. Kaiser's management team, principally Bedford and Kaiser's son Edgar, implemented continuous process refinement. After completing each vessel, supervisors conducted comprehensive reviews identifying bottlenecks and inefficiencies. Which operations caused delays? Where did workers wait for materials or equipment? Which fabrication sequences could be parallelized rather than performed sequentially? These reviews drove steady improvements. The second Liberty ship required 169 days, a 14% reduction. The fifth required 128 days. By April 1942, Richmond yards were completing vessels in approximately 70 days, less than half the traditional construction timeline. More remarkably, quality metrics showed improvement rather than degradation. As workers gained experience and procedures became standardized, defect rates declined and inspection failures decreased. The critical innovation was modular assembly, taken to its logical extreme. Rather than installing propulsion machinery after hull completion, a process requiring weeks of work in cramped, difficult conditions, Kaiser's engineers designed complete engine room modules. The triple expansion steam engine, reduction gearing, shafting, auxiliaries, piping, and electrical systems were assembled as an integrated unit in a specialized fabrication shop with optimal lighting, access, and tool availability. When the hull reached appropriate completion stage, a heavy lift crane lowered the entire engine room module into position in a single operation lasting approximately 8 hours. This approach required extraordinary precision. The engine room module and the hull opening had to match within fractional inch tolerances. Achieving this precision demanded careful dimensional control throughout fabrication, a challenge for workers with minimal experience. Kaiser invested heavily in jigs and fixtures that mechanically enforced proper dimensions, reducing reliance on worker judgment and skill. Similarly revolutionary was the pre-outfitting approach. Traditional ships received interior fittings, piping, electrical systems, and equipment after hull completion, requiring trades to work in confined spaces with limited access. Kaiser's system installed as much equipment as possible into hull sections before final assembly. Cargo hold sections arrived at final assembly with lighting fixtures, ventilation ducting, and piping already installed. This pre-outfitting approach improved both productivity and quality. Workers could access equipment easily during installation and inspection. The competitive dynamic between Kaiser's multiple yards accelerated innovation. Edgar Kaiser managed Oregon Shipbuilding Corporation in Portland, while Bedford oversaw Richmond operations in California. Both locations operated under Kaiser corporate oversight, but maintained substantial autonomy. This structure created internal competition, with each yard striving to outperform the other in production speed and efficiency. During September 1942, Oregon yards completed a Liberty ship in 10 days, a spectacular achievement that received national publicity. This record represented the culmination of 18 months of process refinement. Every operation had been analyzed, optimized, and rehearsed. Materials were staged precisely when needed. Crane movements followed choreographed sequences minimizing wasted motion. Workers understood their specific tasks and executed them with practiced efficiency. Richmond management refused to cede victory. Bedford proposed attempting a sub-10-day construction timeline, an objective that many engineers considered physically impossible regardless of organizational excellence. The limiting factor wasn't worker productivity, but fundamental process dependencies. Certain operations genuinely required specific durations. Welded joints needed cooling time before stress relief. Concrete ballast needed curing time. Systems required testing before certification. Bedford's team conducted meticulous planning throughout October 1942. They identified every operation required for ship completion, determined minimum time for each task, and organized them into the most aggressive possible schedule. The resulting plan called for multiple shifts working simultaneously on different vessel sections, maximum parallelization of independent operations, and immediate availability of all materials and components. The vessel, designated SS Robert E. Peary, was assigned to Richmond Shipyard No. 2, with construction scheduled to commence at midnight on November 8, 1942. The objective was explicit: complete the ship in under 5 days, establishing an unbreakable record that would demonstrate the ultimate capability of Kaiser's production system. Preparation began weeks earlier. All structural components were prefabricated and staged adjacent to the assembly slip. The bow section, stern section, 3 midship sections, engine room module, and deckhouse superstructure sat ready for installation. Each module had been completely outfitted during fabrication. Piping, electrical systems, equipment, and fittings were already installed and tested. This preparation represented hundreds of thousands of worker hours invested before official construction commencement. At precisely midnight on November 8th, crane operators began lifting the keel sections into position. Within 2 hours, the vessel's bottom structure was in place, and welders had begun joining sections. The construction proceeded with machine-like precision, each operation flowing directly into the next without delays or confusion. First shift workers completed scheduled tasks and departed, while second shift teams immediately continued work without interruption. By the morning of November 9th, less than 12 hours after commencement, the hull structure was substantially complete. Welders worked continuously joining the major sections, while fitters installed secondary structural elements. Simultaneously, separate crews began installing propulsion machinery, which had been pre-assembled into modules ready for integration. The massive steam engine, weighing approximately 140 tons, was lowered into position by crane and secured to engine bed foundations within 6 hours. November 10th saw installation of all major systems. Piping crews connected steam lines, fuel systems, ballast systems, and auxiliary machinery. Electricians completed wiring harness installations and connected generators to distribution panels. Deck crews installed cargo handling equipment, masts, and navigation gear. Each trade worked in carefully choreographed sequence, avoiding interference with other operations while maintaining aggressive schedule. By November 11th, the vessel had achieved structural completion. All hull sections were welded and ground smooth. Machinery installation was complete. Outfitting had progressed to final stages. Inspectors from the Maritime Commission conducted rapid examinations, verifying that work met specifications and standards. Some deficiencies were identified: minor weld defects, improper valve installations, electrical connection errors, but all were corrected within hours by dedicated repair crews. The final day, November 12th, focused on testing and final preparations. Engineers brought the propulsion plant online, verifying that all systems operated correctly. Steam pressure reached operating specifications. Generators produced power. Pumps, compressors, and ventilation systems functioned properly. The vessel was mechanically complete and ready for launch. At 3:30 p.m. on November 12, 1942, the Robert E. Peary slid down the launching ways into San Francisco Bay. The elapsed time from construction commencement to launch was 4 days, 15 hours, and 29 minutes. Approximately 1,200 workers had participated directly in the effort, supported by hundreds more in material handling, inspection, and administrative roles. Vice Admiral Land attended the launch ceremony. According to contemporary press accounts, he stated, "6 months ago, I would have considered this achievement utterly impossible. Henry Kaiser has rendered obsolete everything we believed about shipbuilding." The Robert E. Peary represented not merely a record-breaking construction timeline, but validation of an entirely new industrial paradigm. Importantly, the Peary was not merely a publicity stunt. The vessel entered service, crossed the Atlantic, and delivered cargo to Allied ports. While some historians have noted that the Peary suffered from stress cracks and required repairs during its service life, problems attributed to rushed construction, it fulfilled its primary function of delivering essential supplies when they were most urgently needed. The Peary's construction demonstrated what was theoretically possible, but sustained mass production at scale represented Kaiser's true contribution to Allied victory. Throughout 1943 and 1944, Liberty ship production expanded across multiple shipyards nationwide. Kaiser's methods were studied, replicated, and refined by other builders. By mid-1943, the average Liberty ship construction time had declined to 42 days, a figure representing the median across all American shipyards, not merely Kaiser's optimized facilities. This meant that the United States was launching approximately 3 Liberty ships daily, a production rate that far exceeded German submarine sinking capacity. Admiral Karl Dönitz, commander of German U-boat forces, later acknowledged that by late 1943, Allied shipbuilding had rendered the Atlantic submarine campaign strategically futile. Production statistics from 1943 illustrate the scale of this industrial mobilization. American shipyards delivered 1,949 merchant vessels, totaling approximately 19 million deadweight tons that year, more than Germany, Britain, and Japan combined had produced during any previous year. Liberty ships constituted the largest single component of this output, with 308 delivered in 1943 alone. Kaiser's yards represented the most productive segment of this program. At peak operation during 1943-1944, Kaiser managed facilities employed approximately 196,000 workers across multiple locations. Richmond Shipyard achieved maximum employment of approximately 90,000 workers, a figure exceeding the entire pre-war American shipbuilding workforce. This expansion required housing, transportation, medical services, and community infrastructure that simply didn't exist when construction began. Workforce composition evolved substantially during this period. Female workers, initially comprising about 20% of Kaiser's workforce, expanded to nearly 40% by 1944 as male workers transferred to military service. These women, collectively known as Rosie the Riveters after propaganda imagery, worked in every trade from welding to crane operation. Contemporary surveys and oral histories consistently report that female workers achieved productivity levels equivalent to their male counterparts once they gained equivalent experience. The African American workforce similarly expanded, reaching approximately 30% of Kaiser's total employment by 1944. This integration occurred despite persistent discrimination. Black workers typically received assignment to the most physically demanding positions, faced harassment from some white co-workers, and were excluded from supervisory roles. However, the combination of union wages and access to skilled trades represented substantial economic advancement compared to alternatives available to black workers in 1940s America. Kaiser implemented comprehensive social programs to support his massive workforce. Richmond's population exploded from approximately 23,000 residents in 1940 to over 100,000 by 1943, a growth rate that overwhelmed existing housing, schools, and services. Kaiser built housing projects accommodating thousands of workers, though these facilities were segregated by race in accordance with prevailing policy. He also established childcare facilities, an innovation reflecting the large number of female workers with children. Perhaps Kaiser's most enduring legacy emerged from an unexpected source: occupational healthcare. The rapid workforce expansion and around-the-clock operations created substantial medical needs. Workplace injuries, acute illnesses, and chronic conditions required immediate attention to maintain productivity and worker welfare. Kaiser initially contracted with existing medical providers, but conventional fee-for-service healthcare proved inadequate for shipyard needs. Doctors maintained offices in cities miles from shipyards. Workers injured during night shifts had limited access to care. Costs escalated unpredictably as worker populations fluctuated. Kaiser sought an alternative approach that would provide reliable access while controlling expenses. The solution was prepaid group healthcare, an arrangement where Kaiser would pay a fixed per-worker fee to medical groups in exchange for comprehensive care. Dr. Sidney Garfield, who had previously provided prepaid healthcare for workers at Kaiser's Grand Coulee Dam project, was recruited to design a program for shipyard workers. The resulting system, established in 1942, enrolled workers who paid minimal weekly premiums, deducted from paychecks, in exchange for complete medical coverage. Kaiser Permanente facilities were built adjacent to shipyards, ensuring immediate access. Medical staff worked around the clock, matching shipyard shift schedules. The prepayment model incentivized preventive care and early intervention, catching health problems before they became severe, saved money, and kept workers productive. This approach contrasted sharply with fee-for-service medicine, where providers profited from treating illness rather than maintaining health. Enrollment grew rapidly. By 1944, approximately 90,000 shipyard workers and their family members received care through Kaiser Permanente facilities. The program's success attracted attention from health policy experts, who recognized that prepaid group practice could potentially address broader American healthcare challenges. After the war ended, Kaiser converted the program to a civilian health plan, eventually growing into one of America's largest integrated healthcare systems, serving millions of members. The healthcare program reflected Kaiser's pragmatic approach to workforce management. He recognized that healthy, well-cared-for workers were more productive than those struggling with untreated medical conditions. By investing in preventive care and easy access to treatment, he reduced absenteeism and maintained high productivity. The program wasn't philanthropic. It was calculated investment in workforce efficiency that happened to generate substantial worker welfare benefits. By the time Japan surrendered in August 1945, American shipyards had delivered 2,610 Liberty ships, along with thousands of other vessel types. Kaiser-managed yards accounted for approximately 1,490 of these Liberty ships, over half the total production. This output represented roughly 27% of all American merchant ship tonnage produced during the war. The Liberty ships themselves, designed as emergency vessels with expected 5-year service lives, proved remarkably durable. Many remained in commercial service through the 1960s, and a few survive today as museum ships. SS Jeremiah O'Brien, built in 1943, remains operational in San Francisco, maintained by volunteers and occasionally putting to sea for commemorative events. SS John W. Brown serves similar purpose in Baltimore. These preserved examples allow modern observers to examine wartime construction quality firsthand. Post-war investigation revealed some structural problems with early Liberty ships. Approximately 3 vessels suffered catastrophic hull failures. The hull literally broke in two due to brittle fracture propagation from weld defects. Metallurgical analysis determined that early welding procedures and steel compositions created susceptibility to crack propagation under cold water conditions. These failures prompted development of improved welding standards, better steel specifications, and enhanced quality control procedures that substantially influenced post-war shipbuilding practice. Kaiser's modular construction approach and prefabrication techniques became standard practice in global shipbuilding. Japanese yards rebuilding after war destruction adopted these methods extensively. South Korean shipbuilders establishing industry during the 1970s incorporated prefabrication as fundamental practice. Modern shipyards in China, Korea, and elsewhere build vessels in modules that are assembled with methods directly descended from Kaiser's wartime innovations. The influence extended beyond maritime construction. Prefabrication and modular assembly techniques spread into building construction, bridge building, and eventually aerospace manufacturing. The Liberty ship approach demonstrated that complex products could be assembled from standardized components manufactured separately, a principle that underlies modern manufacturing across industries. Kaiser's demonstration that rapid training could produce competent industrial workers influenced post-war technical education. Community colleges and vocational training programs expanded substantially during the 1950s and 1960s, emphasizing practical skills development over lengthy apprenticeships. While traditional skilled trades maintained apprenticeship systems, many technical occupations adopted shortened training programs focused on specific competencies rather than comprehensive craft mastery. The social impact was equally significant. The wartime integration of women and minorities into industrial workforce, while incomplete and often discriminatory, established precedents that civil rights movements would build upon. Women who worked in Kaiser's yards had demonstrated capability in roles previously reserved for men. Black workers who learned skilled trades during the war possessed credentials and experience that enabled post-war economic advancement. These wartime experiences contributed to social changes that would accelerate during subsequent decades. The Richmond Kaiser shipyards closed after war's end, as emergency cargo vessel demand evaporated. The massive workforce dispersed. Some workers returned to previous occupations or locations. Others remained in Richmond and neighboring communities, having established roots during wartime years. The city's demographics permanently changed. Richmond evolved from a small industrial town into a diverse urban center, a transformation directly attributable to Kaiser's wartime operations. Kaiser himself continued his industrial career after the war, pivoting to aluminum production, steel manufacturing, and eventually automobile manufacturing. Kaiser Motors, his automotive venture, produced cars from 1945 until 1955, though ultimately failed to compete effectively against established manufacturers. Kaiser's greatest success remained his wartime shipbuilding achievement and the healthcare organization bearing his name. Admiral Chester Nimitz, reflecting on Pacific theater operations, stated in his memoirs, "Japanese strategists calculated they could destroy our ships faster than we could replace them. They failed to account for American industrial capacity, particularly Henry Kaiser's revolutionary production methods. The decisive campaign wasn't fought at sea, it was won in shipyards." This assessment captures the essential strategic reality. German U-boats sank approximately 2,800 Allied merchant ships during the war. American yards built over 5,000 merchant vessels during the same period. Once American production reached full capacity by mid-1943, sinking merchant ships became strategically meaningless. Losses were replaced faster than they occurred. Kaiser's contribution to achieving this production supremacy earned him recognition as one of the war's most consequential figures, despite never wearing a uniform or designing a weapon. The broader lesson concerns the relationship between industrial capacity and military capability. Modern warfare's outcome depends less on battlefield tactics or operational strategy than on industrial production, technological innovation, and resource mobilization. The side that can produce more ships, aircraft, tanks, and ammunition possesses decisive advantage regardless of tactical skill or fighting spirit. Kaiser's Liberty ships embodied this principle. They weren't elegant, fast, or particularly well built, but there were enough of them delivered when needed to win the Atlantic campaign and enable Allied operations worldwide. From the first contract signed in December 1940 to the final Liberty ship delivered in September 1945, Kaiser's organization produced definitive proof that industrial innovation could match or exceed military capability in determining war outcomes. The impossible construction timeline of SS Robert E. Peary, 4 days, 15 hours, and 29 minutes, represented more than a production record. It symbolized transformation of American industrial capacity from craft-based sequential processes to mass production parallel operations. That transformation, more than any single battle or campaign, secured Allied victory and shaped the post-war industrial world.